guys, Miss Nguyen here with our compound interest notes. Okay, so compound interest is interest that is earned on both the principal, and so remember, principal is the money that you start the account out with, right? Okay, plus any previously earned interest. Okay, so basically the money is continually compounded, hence the name. Okay, so with simple interest, you're only earning interest on the principal. So as soon as you create the account or you borrow the money, you know exactly how much interest you're going to make because it's purely based on that principal you first deposited. When it comes to compound interest, that's different. Okay, the reason why we call it compound is every month or every year, however many times that account gets compounded, they take the interest that you earn, they compound it with the principal that you started out with, and that becomes the new principal. Okay, so even if you don't deposit any more money, your principal just keeps going up and it'll just keep earning more money. Eventually, what you're doing is you're earning interest on your interest. Okay, that's different from simple where you're only earning interest on the principal. Okay, so for compound interest, we have once again two formulas. This first one, this is the one that is given to you on your formula sheet. Okay, and this is the helper formula that you have to memorize, the second one. Okay, now if you remember the helper formula we had with simple interest, that was A equals P plus I. This is really that same formula, we just rearranged it a little bit. Okay, because unlike the simple interest formula, the compound interest formula gives you the account balance. You can see here that the formula for compound interest, it's A equals. So when you get your answer is A. Okay, that's different from simple interest because with simple interest, it was I equals PRT, so your answer is I. So since our answer is given to us as A, we need to use the helper formula whenever we want to find I. So instead of adding, now we subtract, okay? You just think about going to the grocery store. If you are trying to find the total, you're adding together all of the stuff you bought. Whereas if you already have the total, you need to subtract to figure out the interest, okay? Now, it uses all the same letters as simple interest. Okay, so let's just fill this out. A is account balance. We can also, oops, I missed an N. Account balance. This is also total balance. So if you see the word account or total, those are all keywords for A, all right? P is the principal. Even though it's principal, the number one word you're going to see is deposit. R is the rate. Specifically, it is the interest rate. That's what the R comes for, is for rate. This is always going to be a decimal, same as with simple, okay? So whenever you get your percentage, you need to convert it to a decimal. Time for T. Time always has to be in years. Okay, and finally we have the letter I, which of course is interest. This is specifically interest earned or owed, okay? So usually the problem will say something like, oh, you know, if the interest, what is the interest earned? Or if the interest earned was this, then what is the blah, blah, blah. They will always use the word interest for I. Okay. So we just covered this part. Unlike the simple interest formula, the compound interest formula gives you the account balance. It's A equals. So if you want to find the interest, okay, earned or owed, then you have to use the helper formula, this thing right there, to subtract principal from the total. Okay, so if you already have A, then you have to subtract. If you're trying to find A with simple interest, that's when you add, okay? But most of the time with compound, they just want A, so you just need to use the formula as is because you already get A when you use this formula. All right, so let's take a look at some practice problems. Okay, number 1 here, it says a $1,000 deposit for 25 years at a compound interest rate of 2%. Okay, so we have here the word deposit. That tells us that this is P. Okay, 25 years, when you see years, that's time. So this is T. And then it even says rate of 2%, so this is R. Okay, but we can't leave them like that, okay, because 2% is a percent. We need R to be a decimal for us to do this problem, right? So if we take this 2%, we move the decimal point over twice, or you could do 2 divided by 100, either way, you end up with 0.02. Okay, so let's go ahead and write these out. So P is, zoom in, P is 1,000. R is 0.02. And T is 25. You really want to think about R like cents, okay? That's why 2%, the word cent is even in there. So if you have 2%, you want to write it like it's 2 cents, okay? This is different from this. This is not 2 cents, this is 20 cents. And it's also 20 cents is the same as 20%, okay? So since we want this to be 2%, it needs to be written like this. All right, so whenever you're dealing with percents, if you want to deal with it like money, then that can really help. Because when you have $1, that's 100%. 99 cents is the same as 99%, and so on. Okay, so anyway, we have our P, we have our R, we have our T, so we can use our formula. Here it's A equals P times 1 plus R to the power of T. Okay, this is where I want to talk about this really quick. T is an exponent, okay? So you don't want to write it like this, because if you write it like this, you're just saying, oh, I'm multiplying these numbers together. We are not multiplying them together. This is an exponent, okay? So let's fill these in. P is 1,000, and we have the number 1. This is not an I, this is 1, plus the rate, which is 0.02, to the power of 25. So we can put this directly into Desmos. Okay, 1,000, parentheses, 1 plus 0.02, close the parentheses. This is an exponent, so we want to push this button right here, a to the power of b, this exponent, to be our time, which is 25 for 25 years. So we end up with 1,640.60. Now, this is money, so we want there to be 2 numbers after the decimal point. But we need to figure out if we need to round this up or not, okay? So we have 5. 5 or more raise the score, so that means we need to bring the 0 up 1. So this is the same as $1,640.61 once we round it. Okay? And again, this is A, okay? 1,640.61. This is our A. So that means that the answer, we want A here, account balance. So we want to write this right here. Okay, this next one is interest earned, not A, so we want to make sure we write this in the right place. Okay, to find I, for this second part, interest earned, that's where we have to use our helper formula right here. I equals A minus P, right? So I equals A minus P. Well, we just found A, that is $1,640.61, minus P, which is what we started out with, that is $1,000. This is a nice, easy subtraction problem because we just need to get rid of this 1 right here, basically. So it's 640.61. And so that is our interest earned. Okay, so we know this is the amount of money we started with. We started with $1,000. And then after 25 years, the account had $1,640 in it. So if this is what we ended with, and this is what we started with, then the difference between those two things is the amount of money that we actually made. So that's why we subtract to find the difference, because that difference tells us, oh, this is how much money we made. This is the interest that we earned. Okay, let's do it again for number 2. It says a $500 deposit, here again is the word deposit, so this is P, for 72 months, months is time, right, at a compound interest rate of 1.5%. This is R, which again, we need to take this 1.5, change it into a decimal, move it over twice. So there's a 0 here. A cent and a half, basically. So P is 500. R is 0.015, and T is 72 months. But can we leave it like this? No, we cannot, because our time has to be in years. So when we get months like this, we are going to take that divided by 12. 72 divided by 12 gives you 6. So that's the time that we actually have to use in the formula. So again, we use our same formula as before. A equals P times 1 plus R to the power of T. This is a 1. Right. Trying to make this extra clear. So we fill in our numbers. P is 500. 1 plus R is 0.015. T is 6. We plop on over to Desmos. And once we have this typed in, that's kind of nice because we can just use the skeleton of this formula and change the numbers. So principal becomes 500. Our rate, instead of 2%, we have 1.5%. And the time is 6 years. So it looks like now our A comes to 546.72. Okay. The number after the 2 is just a 1, so we don't have to round up. We just leave it alone. 4 or less, let it rest. Okay? So this is A, so that is our account balance right here, 546.72. Okay? So now we get to our interest earned. So I equals A minus P. So that is 546.72 minus P, which is 500. So again, this is a nice easy problem. When we subtract the 500, it's just left with 46.72. I really want y'all to get into the habit of writing out the formulas with all the letters, because that way when you get this answer, you know, oh, it's A equals. Because sometimes what happens is y'all just write this, and you don't know what you get. And so you don't really know, oh, do I put it here? Do I put it here? I don't know. So that's why if you write down these letters as you go, you know exactly what you're solving for. You know exactly what you just got. Okay? All right, I want you to do 3 and 4 on your own using 1 and 2 as a reference. Okay, so same steps, different numbers. Okay, so pause the video, take a second, do that for yourself, and then we move on. Okay, so I want to show you really quick the simple interest notes that we did. You'll notice here that we used the same numbers. Like I purposefully did it this way, that we used the same numbers here in the problem. So P, R, and T are the same on both of these sets of notes, right? So even though P, R, and T are the same, what we got as our answer was a little bit different because it's a different kind of interest, right? So on simple interest, because we find I had I first here. So this is interest earned account balance, whereas in our notes today, we have account balance on top, right? When you look at these, which one of these accounts do you notice made more money? Like which one earned more interest? Compound on the left or simple on the right? Well, compound, we earned $640.61. Simple, we only earned $500. Okay, well, let's try another one. Let's look at number 2. Okay. Okay. Number 2. So $500 deposit, 72 months, 1.5% interest. Okay. Looks like it's the same thing here on number 2. On compound interest, we earned $46.72. And with simple interest, we only earned $45. So it's not as dramatic a difference because the principal wasn't that high, but still, you can definitely see that with compound interest, we earn more money. Well, that makes sense because with compound interest, every year, your principal is getting bigger because it keeps compounding the interest that you earned the year before with that principal to keep going up and up and up, right? So what that means, okay, is that as long as P, R, and T are the same, you will earn or owe more money when using compound interest, always. Now, that doesn't mean compound interest always makes more money than simple interest, because, yeah, if you have a way higher principal with simple interest, or maybe the rate is super low, like those things are different, then maybe in some cases a simple interest account will make more money. But if P, R, and T are the same for both, the compound interest account will always make more money than the simple interest account. Okay. Now, the reason why I think compound interest is a little bit easier than simple is that there is no pyramid for compound interest, okay? A compound interest problem will always be asking you to find A or I, okay? Every now and then, oops, there. Every now and then, very rarely, you will get a question that asks for P. Okay? So really quick, I want to hop over to our interest practice, which if you're watching this video, you should already have that. So let me pause this for a moment, get that open. Okay. So this is number 6. Right? So this is one of those rare problems where it's compound, but they're going to ask you for something other than A or I. So I'm going to go ahead and show it and put it here in this video. Okay, so this problem says, Cody made a deposit into an account that earns 4% annual compound interest. After 24 months, the value of his account was $2,163.20. What was the amount of Cody's initial deposit? Okay, we see the word deposit here. That means that this question is asking us for P. Like I just said, we rarely, every now and then you'll get a problem like this where you ask for P. Okay, so let's try and work this out. Okay, it says 4% annual compound interest. This is our rate. If we change this into a decimal, remember 4% is the same as 4 cents, so this becomes 0.04, right? Then it says 24 months. This is time. Again, we can't leave it like this because this is in months, so we take 24, divide it by 12, we get 2 years. Then it says the value of his account was $2,163, okay? We see the word account. Account balance, value of his account, that is A, okay? So A is 2,163.2, T is 2, R is 0.04. We can write that here. So we don't know what P is, that's what we're trying to find out, but we do know that R is 0.04, T is 2, and A is 2,163.2. Okay? So our formula, let me give myself some more space. Our formula for compound interest is A equals P times 1 plus R to the power of T. Okay, the problem is we don't know what P is, but luckily we know what these other things are. So let's fill in the other things that we do know. So we have 2,163.2 for A equals P, which we don't know what P is, so we'll just leave it as the letter P, times parentheses 1 plus 0.04 to the power of 2. Okay, well now we've just made this into an equation. There's only one variable, so we can solve this. We can do this. Okay, well, you know that when we are solving an equation, we can divide by the coefficient to get rid of it, right? Because we want P to be by itself. So we need to get rid of this thing right here, right? Well, this is a little messy and hard to deal with, so why don't we go ahead and multiply this out and see what we get. Okay, so let's go back to Desmos. This is 1 plus 0.04 to the power of 2. So that shows us that we get 1.0816 is this number, right? So leave this alone. We didn't do anything on the left side. Equals P times 1.0816. Or, you know what? Let's rewrite this in a way that we can really recognize it. Make this the coefficient, so 1.0816p. Now you can really see that this is a coefficient. Remember, a coefficient is just a number that's being multiplied by a variable. It's stuck to the variable like this. Okay? Well now, hopefully you know, you can remember how we get rid of it. Let's just divide. Divide on one side, we divide on this side too. So this turns into 1. So this would just be 1p, but remember when we have 1 as our coefficient, we don't have to write it. So this is just p equals this. Let's divide that. Okay, so 2,163.2 divided by 1.0816. Hey, look at that. We get a nice even number. It's 2,000. So that is our answer. This is the initial deposit that he made, and then after he left it in there for 2 years, it became $2,163.02. Okay? So this is one of those rare problems where it's a compound interest problem, but they're asking us to find P. So like I said, which I did want to demonstrate for you, but like I said, most problems here, compound interest problem will pretty much always be asking you to find A or I. That was a very rare instance. Hopefully now that you've seen it once, you kind of understand. Right? So fun fact, the compound interest that we are calculating in 8th grade math assumes that interest is only compounded once a year. You don't have to write this part down, but technically, the compound interest formula, the real one, looks like this. Okay, so N is where we put in how many times your interest is compounded. Like, you know, for savings accounts or credit cards, they usually compound your interest every month. So there's 12 months in a year, so it should be like this. Right? But for 8th grade math, we're just assuming that it's compounded once a year. And that's why we write it the way we do, because when you have a number divided by 1, it's just the number. When you have a number times 1, it's just, you know. So that's how we got the formula the way it is now. The more complicated the version of the formula, you might have to use that later in algebra or high school, but, you know, be thankful. That's one thing you don't have to worry about this year. Okay, so compound interest is used a lot in business and finance, so here's some examples of places where we can find it, like savings accounts, investments, stocks, loans, and credit cards. Basically, almost everything that we didn't use simple interest for. So recap, simple interest is used for mortgages, so house payments, car payments, appliances, and furniture payments, okay? Because those things are very expensive. So even if they wanted to charge compound interest, people probably wouldn't be able to afford it. But everything else, loans, you know, the bank is trying to squeeze as much money out of you as possible, so they make it compound interest, okay? Now the next couple of problems are your practice problems. You need to do these on your own. I wanted to try to give you a lot of experience with different ways that these problems can be worded. But I do want you guys to really pay attention to what is this question asking for. Okay, so let's look at number 5. It says, Carlos deposits $44,100 into the bank at 4% annual compound interest. How much money will be in his account after 18 months? First of all, when you see the word annual or annually, okay, that only comes about when you have compound interest. It doesn't mean anything. It's just, remember how I was talking about the more complicated version of this formula has that N in there? This is basically telling people like, oh, N is 1. So for 8th grade math, you really don't have to think about it, except when you see annual and compound, that lets you know, oh, this is a compound interest problem, so I should be using the compound interest formula. That's all that means, okay? So don't get tripped up. Don't try to think that that means you have to do something extra. It doesn't. All of these say that. Here's annual. Annual. It's always there, okay? Anyway, so how much money will be in his account after 18 months? Okay, what is this question asking us to find? It says, how much money will be in his account? That is the letter A. So that means we can just use our formula, our regular compound interest formula, solve for A. When we get our answer, that's just the answer, okay? Whereas, let's look at a different one. Look at number 8. 8 says, Amy decides to get a head start on her retirement fund and puts $5,000 into a Roth IRA that offers 9% interest compounded annually. How much interest will the account have earned at the end of 20 years? This says how much interest. The question, what we're trying to find is interest. That is I. So that means, okay, you always have to find A first. That comes first. It does not look like a 1. 1 plus R. So we have to find A first. And then you can use your helper formula, I equals A minus P. So this one you have the extra step where you have to subtract to get the answer. So I really want y'all to pay attention when you're reading these problems, that you understand what the problem is asking for. Because if you give A when the problem wants I, or you give I when the problem wants A, that is the wrong answer. You will get it wrong, and it's very sad. Because you could do all your work right, but still give the wrong answer if it's not the one being asked for. Okay? So these 4 you need to do on your own. I'm going to combine these 4 with that other assignment, this interest practice, as 1 grade. Okay? So you need to make sure that you not only do this assignment, but that you do this one as well, because it's all 1 grade together. All right? That's about it. Hopefully this was helpful for you.